Good afternoon, my dear students. So today in this sessions we are going to learn very interesting topic is the local and global coordinate systems of a truss element. Local and global coordinate of a truss element. So let us see this figure, then you can easily understand. This is the truss element with the local coordinate figure, and this is another one is the truss element due to the applied load with global coordinate system. So this x coordinate and this is the y coordinate, in which one bar they having the two node, first node and second node. The truss element, this truss element is having two node first and node second in a local coordinate system, in which this prime axis x dash, clear, this prime axis x1 dash is passes through the node from first node to the second node. If we apply the load on the local coordinate system, then the trusses attain a new position. Then trusses attain a new position like this. So it will be inclined positions. Is it right? So this locally the node 1 has the displacement as q1 dash, okay, and the node 2 has the displacement as q2 dash, clear? So but in the global coordinate system we have 2 degree of freedom. We have 2 degree of freedom. For example, let us see this x displacement. This x displacement of node 1 as q1, node 1 as q1, and the y displacement of node 1, I'm talking about node 1 as q2, clear? Node 1 as q1, this is q1, and in the vertical direction, so it is represent as q2 in a vertical, clear? Done. The corresponding value of the node 2 are q3 and q4. The corresponding value of node 2, they are having q3 and q4. So therefore we can say that the q1 dash and q2 dash are the local coordinate system. q1 dash and this q2 dash are the local coordinate system. But q1, q2, q3 and this q4 are the global coordinate system. q1, q2, q3 and q4 are the global coordinate displacement vector, we can say. So in a global local coordinate displacement are represented by q2j. So in x direction we can represent here q2j minus 1. In a vertical axis is q2j only, 2j, clear here? So let us see the example, then you can easily understand. So the local and global coordinate systems are here same, but in the truss element the local coordinate systems are differ for each of the truss element. So the truss element having the first node, they having the first node and the second node in a local coordinate system, and okay, here is one which passes through the point is prime axis is x dash, already we explained. Is it right? So and locally node 1 has a displacement as q dash, and node 2 has a displacement is q2 dash. Node 1 has a displacement is q1 dash, and node 2 has a displacement is q2 dash. Already we have discussed. Is it right? But in the global coordinate system, each of the node will have the 2 degree of the freedom. The x displacement of node 1 as q1 and the y displacement node as q2. Clear? Then, so direction of the cosine, that is the most important here. So the direction of cosine are the cosine of angle between the local coordinate system and corresponding the global coordinate system. Let us see this cos theta. The cos theta in the form of cos theta nothing but base by hypotenuse. We can say, clear here, base by hypotenuse. So here, let us see from here. This is what we can say q1, and this is we got one more point here q2. Observe here about this figure in the global coordinate system. This is our q2. This q2 is making the displacement as a. Sure dear? I hope so, no one is having doubt. But this trusses is making the angle of theta with the horizontal axis. Clear? So from here to here is a displacement, from here to here is b displacement. So we can represent here cos theta is equal to base. Base is how much we got in here? We got the base is as a. Base we got as a. And displacement, or we can say as hypotenuse. What we can say here? Hypotenuse as q1. Let us see this here, hypotenuse. So this is our base, and this is our hypotenuse, and this is our opposite. Clear? And the base is how much we got? A by q1. The base is a and hypotenuse is q1. A by q1 we can say cos theta. Cos theta is equal to a by q1. If you cross multiply here, then it should be q1 cos theta. It's become as equation number 1. Similarly, if you want to find out b value, then you have to go for, because b is acting in a vertical direction. Let us see over here. So this is the b part. Okay, so b by cos theta is equal to b by q2. We can say that because this q1 is in horizontal direction and this q2 is in vertical direction. Already I told you here q1, the q1 in a horizontal direction, and this q2 is in vertical direction. Don't be confused here, don't be confused. So just we need to, this inclined value position is there. If you keep as it is here, it become as this one we can say as q, this one is q1 and this one we can say as q2, vertical directions. Clear? So sin theta is nothing but b by q2. So b here, the base sin theta nothing but y by r. Here sin theta nothing but y by r, means opposite by hypotenuse. So here if you observe this figure, this one is our opposite, okay, and here, and these positions become as hypotenuse. So that's what we can represent here. Sin theta is nothing but b by q2. Otherwise don't be confused here in the examination point of view. Let us see. So just you need to know about it. Cos theta nothing but a by q1. Okay, so just you need to cross multiply here. A is equal to q1 cos theta. It become as equation number 1. Similarly, if you want to find out the sin theta in the vertical direction, this is the x direction, this is the x direction, and this is the y direction. Clear? Done. So let us see. If you want to observe here, this is in x direction is, which one is in the horizontal direction? q1 is acting. So for that reasons I represent here a by q1. In the vertical direction is q2 is acting. That's what I represent as b by q2. B by q2. After that you need to cross multiply this value sin theta into q2 it become as B equal to Q2 sin theta. So A value is Q1 cos theta, it is considered as equation number 1. B equal to Q2 sin theta, it's considered as equation number 2. After that, we need to add equation number 1 as well as equation number 2. So equation number 1 is A toward the left side, equation number B is so toward left side, A plus B, okay, as well as A value is Q1 cos theta, B value is Q2 sin theta. So we know very well the Q1 cos theta plus Q2 cos theta nothing but we can say as Q1 dash. What we can say here? We can say as Q1 dash. So Q11 dash, already we have studied that Q11 dash, we can say that the local nodal displacement. What we can say here? Local nodal displacement we can say. Similarly at the node 1, Q1 dash same as it is I am representing, because we are discussing about this first node as well as we are discussing about second node. Okay, first of all we are talking about node 1. Similarly at node 1, Q1 dash is equal to A plus B. So A values how much is there? A value we know the value is Q1 cos theta. Q1 cos theta. So B values how much is there? Q2 sin theta. So it is considered as equation number 3. So similarly at the node 2, clear? So Q2 dash is equal to, so we can say here we are resolve the forces in Q3 and Q4. At node 1 is resolve the forces is Q1, Q2. At the node 2 we are resolve the forces is Q3. First is Q3, another one is Q4. Clear? So that's what we can represent here, Q3 cos theta, and vertical direction Q4 sin theta. Horizontal direction Q3 cos theta, vertical direction is Q4 sin theta. I hope so you don't have any doubt. Clear? Again it will be considered as equation number 4. After that we need to write above equation in a systematic form Q1 dash here, Q1 dash, Q1 dash, clear here? So Q1 dash equal to Q1 cos theta plus Q2 sin theta. So Q2 dash is equal to Q3 cos theta plus Q4 sin theta. Clear here? Then, so about this equation we are writing in the matrix form. So Q1 dash Q2 dash is equal to, so here let us observe this figure. Here we have Q1 cos theta, Q2, but we don't have the Q3 and Q4. That's what we need to consider here. Q3 cos theta value we don't have, so that's the reason we need to multiply by 0 plus Q4 0. Clear? Q3 is 0, Q3 is 0, Q4 also 0. So after that here in the Q2 dash we don't have the value of Q1 and Q2. So here Q1 0 plus Q2 0. So how to write it in the matrix form dear? First of all we need to take the common term here. This is the Q1 value, Q2, Q3, Q4. Clear? Q1 we have the value is cos theta. In Q2 we have the value is sin theta. But in the Q3 we don't have any value. For that reason I am representing the 0. And in the Q4 we don't have any value. So for that reason I am considering the value of 0. Clear? But come to the point here. In a Q1 we don't have any value. For that reason we are considered 0. In Q2, clear? We don't have any value. We don't have the value means you need to consider the value as 0. Q3 we have the value is cos theta. Q4 we have the value is sin theta. So in the bracket we have to present here Q1, Q2, Q3, Q4, Q1, Q2, Q3, Q4. Okay dear? I hope so no one is having the doubt. So So this q1 dash and this q2 dash we can say as the local nodal displacement. What we can say here? Local nodal displacement. This cos theta sin theta 0 0 0 0 cos theta sin theta we can say as transformation matrix. What we can say here? Transformation matrix. q1 q2 q3 q4 we can say as global nodal displacement. What we can say? Global nodal displacement we can say. After that, so it is considered equation number 5. Clear here? Then after that, this cos x dash x. So you need to observe this figure. X dash x is equal to cos theta I am representing here. So let us see about the figure, then you can easily understand. So this x dash into x, we can say that cos theta value. What we can say? Cos theta value. In this way, let us see. I will draw this figure here. This is theta and this is x dash. This is x direction and this is y direction. Clear? And x dash, they are making angle of here horizontal cos theta, in a vertical sin theta. Clear here? So let us see this x dash into x, x dash into x, what we can say here? Cos theta. What we can say here? Cos theta. X dash into y, what we can say here? Sin theta. What we can say here? Sin theta. Let us see cos x dash into x. Is it right? What we can say? Cos theta. Cos theta nothing but L value we are considering from our side. Okay? As well as cos x dash into y dash. What we can say? I told you this x dash into y dash we can say as sin theta. Clear? We can represent in this way also. Cos 90 minus theta equal to sin theta. Sin theta is considered as m value. So after that we need to write in this form also. Instead of cos theta we can represent as L. Instead of sin theta we can represent as m. This L m 0 0 0 0 L m. Clear? So it is considered as equation number 8. After that this whole the value we can represent as q dash, this whole the value we can represent as L, and this whole the value we can represent as q. This q dash we can say as the local nodal displacement, and L we can say as transformation matrix. This one we can say as transformation matrix, and this one we can say as a global nodal displacement. After that we need to find out the calculation of direction cosine in a truss element. So we have considered a truss element as shown in a figure. If the location of primary node, we have the two primary node, node 1 and node 2. So node 1 we need to assume as x1 y1, and node 2 we need to assume as x2 y2. So the length of the truss element we can represent here, L is equal to, we can represent as cos theta. Cos theta value is x by r, x nothing but base by hypotenuse. So here base is how much is there? We have the base is x2 minus x1, okay, and hypotenuse is how much is there? LE. Clear? And m nothing but sin theta. Sin theta nothing but opposite by hypotenuse. So here we have the opposite is how much is there? y2 minus y1, and hypotenuse is how much is there? LE. Clear? After that we need to represent in this form LE value. LE whole square equal to here L square plus m square. Clear? So here L square nothing but how much we got it here, or we can say as, otherwise don't be confused here. So otherwise you can represent here LE is equal to LE equal to x square plus y square. Okay, so here x is, how much is there? x2 minus x1 whole square plus y nothing but y2 minus y1 whole square. If you remove this square, it make as the root. Okay dear, so I hope so all students got the concept regarding these derivations.